In the past several videos, we've been solving systems of linear differential equations that were homogeneous, where there was no extra function of t added to the x and the y coefficients. So what we're going to take a look at in today's video is answering the question, how do we solve non-homogeneous solutions or systems? And the answer is the exact same way we solved non-homogeneous linear equations when we just had one equation. We're just going to extend it into the matrix form for the multiple equations. And what we did back several chapters ago was we used the method of undetermined coefficients, where we guessed the form of y particular. Now, we also talked about a method called variation of parameters. There is a way to do variations of parameters with the matrices. We just unfortunately don't have time to get into it in this class. So we're just going to do undetermined coefficients. And so if you remember with undetermined coefficients, we would look at the form of the problem. If the problem had something like 3x squared plus 2x plus 1, we would be able to guess the form of y particular by just putting coefficients in front of the key parts. You'll remember that polynomials, we just use ax squared plus bx plus c. Or if there was 2e to the negative 3x, we would know it'd be something times e to the negative 3x. If there were sines and the cosines involved, maybe 3 sine 4x minus 2 cosine of 4x, we knew that meant we were dealing with a sum or difference of sines and cosines. So we would have a sine of 4x plus b cosine of 4x. And then if we had to account for linear independence, something like 5t e to the 6t, we would know that means we have some t e to the 6t plus the linearly independent just b e to the 6t. And then we could work out the problem to figure out what our a's, b's, and c's, and whatever letters were to find those undetermined coefficients. We're going to do much the same thing with our matrices. One thing to keep in mind, though, is if a part is missing from the problem, you still need to include it in the form of y particular. So for example, if the problem, maybe it has something like 2x. What we don't have in the form of y particular is we don't have the constant term, but we need to know polynomials are going to count down from the x to the b. If the problem only had maybe 4 cosine of 3x, it's missing the sine. Y particular might have the sine. So we would do a sine of 3x plus b cosine of 3x. So you do need to make sure you include all the parts counting down, or the other half, even if it's not included. Okay, so basically what we're going to do is, if we know the general forms from undetermined coefficients from before, we just extend that idea to the matrix. So if the problem had maybe a 3e to the 2t and maybe a 4, the form of our y particular could be guessed to be something times e to the 2t. But then we also need to account for the constant. Actually, I'm going to call it b. We'll go alphabetical here. And we need to do it for each row. So the second row is going to be a c e to the 2t plus d. Kind of combining both equations together to get that form of y particular. And then once we find y particular, we know the general solution is x equals the x complement plus the x particular, or y equals y complement plus y particular. The complement we already know how to solve because that's the homogeneous like we've been solving in the prior videos. The particular is what we're adding to the problem today. All right, so if we already know how to solve these, we're just extending it to matrices. Let's look at an example where we solve x prime is equal to 4x plus 2y plus t, and y prime equals 3x minus y minus 4. Well, let's put that into matrix form. Our matrix x, which is our variables, prime, is equal to the coefficients of 4, 2, 3, and -1 times our variables. But now added to that, this is the non-homogeneous part, are those functions of t and -4. Let's look at solving these. The first thing we want to do to solve is to solve for x complement. Well, this is what we've been doing in our prior videos. We use the eigenvalue method, 4 minus lambda, 2, 3, -1 minus lambda, which means we have 4 minus lambda times -1 minus lambda, minus 2 times 3 is 6, equals 0, which means we've got -4 minus 4 lambda plus lambda squared minus 6 equals 0, which is lambda squared minus 3 lambda minus 10 equals 0, which means we've got lambda minus 5 times lambda plus 2 equals 0, and lambda is equal to 5 and -2. So we look at, well, if lambda equals 5, we're dealing with 4 minus 5, plugging in for the lambdas. 4 minus 5 is -1 and 2. 3 and -1 minus 5 is -6. We multiply by the eigenvector AB, which gives us -a plus 2b equals 0, and 3a minus 6b equals 0. First equation looks simpler, so if I add a to both sides, we get 2b equals a. If I let b equal 1, we end up with the eigenvector where b is 1 and a is 2 times 1, which is 2. Then we look at what happens when lambda is equal to -2. Plugging in for the lambdas, we get 4 minus -2 is 6. 2, 3, and -1 minus -2 comes 1. Multiply it by the AB, and that gives us 6a plus 2b equals 0, and 3a plus b equals 0. This time the second equation is simpler. We'll subtract the 3a, and then I'm going to let a equal 1 this time. So if a is 1, b is -3 times 1, which is -3. So, putting that all together, we end up with our matrix x complement is equal to C1 times 2, 1, e to the 5t plus C2 times 1, -3, e to the t. Okay, that much is review from what we've been doing all the way along. We're going to hold on to that to be used here in just a minute. Now that we know what x complement looks like, we're going to guess the form of x particular and use those undetermined coefficients. So if I remember correctly, the equation up above, just because it's off my screen, I'm going to write it again. We said x prime equals 4, 2, 3, negative 1 times our x vector plus a t and a 4. And so now I'm looking at that non-homogeneous part, the t4, so I can guess the form of x particular. Since we've got a linear term and a constant term, I'm going to guess it's a times t plus b and c times t plus d. And if I know what x particular is, we can quickly find what x prime is. The derivative of x particular is equal to a and c. Now we're going to plug those values into our equation. So x prime is ac equals 4, 2, 3, negative 1 times x. Well, x we said was at plus b and ct plus d plus the vector t4. Now we'll use undetermined coefficients to solve for a, b, c, and d. It's going to be a little bit of algebra to get there, but nothing bad. If I just work across the first row is a equals, multiplying a row times a column, we've got 4 times at plus b plus 2 times ct plus d plus, first row has the t in it. And the second row then is c equals, second row times the column, 3 times at plus b minus 1 times ct plus d, and we have a plus 4 at the end. This is going to give us the pieces we need to solve. I'm going to go ahead and multiply everything out. So we've got 4at plus 4b plus 2ct plus 2d plus t. Put a little squiggly here so we don't get these mixed up. C equals 3at plus 3b minus ct minus d plus 4. To solve these, you'll notice some of the terms have t's and some of the terms are just constants. If I just look at the t's from the equation on the left, there are 0 t's equals 4at plus 2ct plus a t. In the second equation, there are 0 t's on the left is equal to 3a minus c. Oops, up above I said plus t. I meant plus 1. There's 1 t. We're talking about how many t's. So 3a minus c equals 0. For the constants, I've got a equals 4b plus 2d. A equals 4b plus 2d. And from the second equation, c equals 3b minus d plus 4. And these are the equations we need to solve in order to find a, b, c, and d. For the first equation, I'm going to move the 1 over to the left. And I'm also going to multiply the second equation by 2 to get opposites in front of c. When I do that, I get negative 1 equals 4a plus 2c. And, oops, 0 times 2 is 0, equals 6a minus 2c. So I have negative 1 equals 10a. Divide both sides by 10, and a equals negative 1/10. Okay, let's find c then. I'm just going to plug it into the second equation here, which was 0 equals 3 times a, which is negative 1/10, minus c. If I add c to both sides, I get c equals negative 3/10. And we've got our c. Well, that's going to be helpful because now I know the a is equal to negative 1/10. And I know the c is negative 3/10. So now I know what these equations equal on the right side. And now I have two equations and two unknowns. I'm going to multiply the second equation by 2 because that's going to clear everything out. So when I do that, I get negative 6/10. Do I want tenths? Actually, let's reduce that. Let's call it negative 3/5. Negative 3/5 equals 6b minus 2d plus 8. The other equation is negative 1/10 equals 4b plus 2d. And so when I add those together, maybe I shouldn't have reduced because now I need a common denominator. 6/10, fine. So that gives me negative 7/10 equals 10b plus 8. If I subtract 8 from both sides, that's 80/10. So negative 87/10 equals 10b. So b is equal to negative 87 over 100. And now that I have b, let's plug it into, I'm going to go with the first equation here. Negative 1/10 equals 4 times b, which is negative 87 over 100, plus 2d. I'm going to get rid of the fractions and multiply everything by 100, which gives me negative 10 equals 4 times negative 87, which is negative 348, plus 200d. Add the 348 to both sides. We get 338 equals 200d. Divide by 200. And I think we get 169 out of 100. All right. So let's review. I said x particular was equal to a times t plus b and c times t plus d. Well, now that we have each of those values, we can say x particular is equal to a, which is negative 1/10 t, plus b, which is negative 87 over 100. C, we said, was negative 3/10 t, plus d, which is 169 over 100. And we have our x particular. A lot of algebra to get there, but not really difficult algebra, very doable. And now that we have x particular and x complement, we know the solution is the x vector is equal to x complement vector plus x particulars vector. Or in our case, if you remember from up above, x is equal to c1 times 2(1) e to the 5t plus c2 times 1 negative 3 e to the negative 2t plus the x particular that we just found, which is negative 1/10 t minus 87 over 100, and negative 3/10 t plus 169 over 100. And we have found our solution for our non-homogeneous differential equation system of linear equations. These are just a bunch of algebra, but not really difficult to actually work out. So practice a few of these out of the text. Let me know if you have any questions. I'm here to help.